So we are not allowed to have radicals in the denominator. That's a rule of fractions. So what we need to do is rationalize the denominator. Basically means get rid of the radical. So in order to get rid of a square root, we need to do the inverse operation, which would be squaring. So if we square radical 3, that's multiplying it by itself. And if we multiply by itself on the bottom, then we also need to multiply by itself on top. Now, and when I say by itself, when we multiply by radical 3 on bottom, we have to multiply by radical 3 on top. So on top, we get 10 radical 3, outside times outside, inside times inside. On the bottom, radical 3 squared or times itself is just 3. And then we would try to simplify this fraction. Remember, you can only simplify things outside the radical, not inside, but it does not simplify, so that would be our final answer. All right, we'll do a more complicated one that has coefficients outside. So here we just need to make sure, again, we keep outside with outside, inside with inside.
Can I have a custodian to the dock door for a delivery, please? Thank you.
So here we need to multiply radical 7x by itself. So instead of square rooting, we need to square it. If we do that on the bottom, we have to do it on the top. Now notice I didn't include that 3. That 3 is fine. It's not a radical, so we can just leave that there. So now when we multiply it on top, we get 5 on the outside, and we get 14x on the inside. And on the bottom, radical 7x times radical 7x is 7x. And then 3 times 7x would be 21x. And then we would try to simplify it, but it does not simplify there, so that's our final answer. All right, now we also have examples where we could have a cube in the denominator, a cube root. So here we have a cube root of 7x over cube root of 5y squared. So since this is a cube root, we have to do the inverse operation to get rid of that radical, which would be cubing it. Well, cubing it would be multiplying by itself 3 times. We already have it here once, so we need to multiply it an additional 2 times so that we have 5y squared now cubed. That should be index of 3. So if we have 5y squared, cube root cubed, those will cancel, and then we're just left with 5y squared. Now what do we have on top? Well, we also would have to multiply it by 5y squared 2 additional times to make it a total of 3 on the bottom. So here we would have a cube root. 7 times 5 times 5 would be 175. X times nothing. And y squared times y squared would be y to the 4th. And now we can simplify this. 175 does not have any factors that are cube roots, but here we have x, which cannot come out, but y can. Here we have 4 y's. We could take y cubed out, and we'd be left with 1y. So we can write this as y cubed times y. The y cubed can come out, and that would be just y, since we're cube rooting it. And then we're left with 175x and the y that's left over the bottom, which is 5y squared. And then even more so, we can simplify with this 1y on top with one of the y's on bottom and change that into just y. So our final answer would be cube root of 175xy over 5y. All right, now over here, a little bit more room. Last one. Our last one is going to have one on the inside and the outside and be a cube root. All right, so same thing again, we need to do the inverse operation. So that would be multiplying by itself 2 additional times to make it a total of 3 times, which would give us just 5x on the bottom. And we also have to do the same on top. Here we have outside 6x and then inside 5x. Oops, that should be 25. We have to multiply those two together. 25x squared. And 25x squared does not simplify out of a cube. There's no cube roots. But here we do have this, which will simplify on the outside to 6 25x squared over 5. And again, that would be your final answer. And make sure as you're doing these, you're always looking for absolute values unless it says assume all variables are positive, which it will say on your worksheet for this section.